Section 5.3 is about solving trig equations. So our goals are to solve trig equations by finding a general solution and the exact solutions to them. We're also going to use trig identities to solve trig equations, kind of part of point one as well. We're also going to solve trig equations that are of the quadratic type. We'll talk about what that means more in a little bit. So solving trig equations is very similar to solving algebraic equations. Essentially, you isolate the x by using inverse operations and working backwards. So, for example, this graph here is a graph of a sine wave. Now, if you're just solving for x, if you're solving for x and sine of x equals to 1/2, it's got two solutions of pi over 6 and 5 pi over 6. And we're focusing on the interval of 0 to 2 pi. So, a couple reasons for why we want to focus on 0 to 2 pi. So, for this, we're going to say the reason we're focusing on that is the period is 2 pi. And if we were to go outside of that, there would be infinitely many answers. Now, that doesn't mean that the other answers outside of that range are irrelevant, but we're going to talk about how to describe them without having to list off every single one. So, talking about specifically sine and cosine functions, the period of a sine and cosine function, they share the same period, is 2 pi. And so that means we're going to use the range that we have on that graph there. So we're going to say 0, 2 pi. And just a quick refresher on this notation, what this really means is 0 less than or equal to x less than 2 pi. We're not saying less than or equal to 2 pi, just strictly less than, because once we hit 2 pi, the sign at 0 and the sign at 2 pi are the exact same. They're coterminal angles. So we're only going to use 0 to 2 pi, but not including 2 pi. For tangents, the tangent period is much shorter. In fact, it's half as large. So the period is just pi. So that means for our domain, we're going to use 0, pi. And so we're only going to go from 0 to pi. Now we're going to take a look at a couple examples on this next page, and we're going to figure out how to solve. So we're going to solve this very algebraically. We're going to solve sine of x plus the square root of 2 equals the negative sine of x. And again, here's some hints. Get all the signs to one side and the numbers to the other, kind of like what we do with an algebraic equation. So in order to do that, let's add sine to both sides. So we got add sine of x to both sides. And we got 2 sines of x on the left side here, plus the square root of 2 equals 0. Now to solve for x, we got to get rid of everything on that side that's not x. So let's subtract the square root of 2 from both sides. So we have 2 times the sine of x equals negative square root of 2. To keep solving for x on that side, let's divide both sides by 2. And we got the sine of x equals negative square root of 2 over 2. Now we can go to our unit circle. Let me open up my unit circle. And we can look at what values of x make sine equal to negative root 2 over 2. Remember, the sine is the y value, so we're looking down here and down here. So we're going to say those two angles at 5 pi over 4 and 7 pi over 4. So, there we go. So we're going to say x is equal to 5 pi over 4, and I'm going to leave a little bit of a gap, and I'll show you why in a second. And we got x equals 7 pi over 4. Now I'm leaving a gap because I'm going to put some more information between these. So 5 pi over 4 and 7 pi over 4. The reason I want to bring this up is sine of 5 pi over 4 is in fact sine of 5 pi over 4 is negative square root of 2 over 2. But that's not the only option. I mean, obviously 7 pi over 4 is as well. So again, sine of 7 pi over 4 equals negative root 2 over 2. But there's technically more. Now, the way we're going to describe them more is we're going to talk about the coterminal angles. So, coterminal, just as a refresher, starting off on the positive x-axis, and if we go to 5 pi over 4, that's one angle that has a sine of negative root 2 over 2. But if we do another full circle on top of that, we end up with the same coterminal angle. We have the same sine of negative root 2 over 2. And if we get another one, and another one, and another one, you can keep on going in a circle forever and ever and ever, and you still end up with the same coterminal angle, which means you end up with a sine of negative root 2 over 2. So to describe our coterminal angles, we're going to say plus full circles 2 pi times n. Now n could be positive, n could be negative. So it could be positive coterminal angles like we were doing here. So we got a positive coterminal and a positive coterminal. Or it could also be a negative coterminal angle. That would just be down here. So the plus 2 pi n kind of covers all the bases, saying 5 pi over 4 plus any coterminal angles. Now, same thing for 7 pi over 4. We're going to say it's plus any coterminal angles. Now again, that 2 pi comes from the full circle, in other words, what the period is of sine and cosine. Example number 2, it says solve 2 times the sine squared of x minus sine of x minus 1. Now the hint we give here, it says say you replace sine of x with x, and in fact, just to reduce confusion, let's make it t. So I'm going to start off by making this 2 times t squared minus t minus 1 equals 0. Folks, this is kind of going into that third bullet point where we're talking about solve trig functions that are kind of like quadratics. This one, 2t squared minus t minus 1, we can factor that out. And it would factor out into 2t plus 1 and t minus 1 equals 0. Now, if we're just kind of replacing, again, we're just saying sine of x equals t. Well, that means we can plug sine of x back in. So it'd be 2 times the sine of x plus 1 times the sine of x minus 1 equals 0. Now, thinking about what we know about multiplication and what we end up knowing about factoring, each of these two groups could be equal to 0. The zero product property says if we have one thing times another equals 0, then either the first thing, so in this case sine of x plus 1 equals 0, or the second thing, sine of x minus 1 equals 0. To solve for x, on that left group, we're going to subtract 1 from both sides. We get 2 times the sine of x equals negative 1. To keep solving for x, we're going to divide both sides by 2. And we end up with, I'm running out of space here, but this is going to work out. Sine of x equals negative 1 over 2. Now, if we go back to our unit circle, we're looking for where the sine of x equals negative 1 over 2. Sine of x equals negative 1 over 2 here and over here. So 11 pi over 6 and 7 pi over 6. So let's write that down. So x equals 7 pi over 6 and 11 pi over 6. We'll take care of the coterminals in a little bit. On the other one, let's add 1 to both sides, and we end up with sine of x equals 1. And thinking about what x values make that true, that'd be x equals, not pi, but pi over 2. Again, looking for the y value, looking for the sine value of 1, that's up here, so we're at pi over 2. So our x values, our solutions, we're going to say x equals 7 pi over 6 plus the coterminals. So remember, coterminals have to do with the period, so we got plus 2 pi n. Another value would be x equals 11 pi over 6 plus 2 pi times n. And the final one would be x equals that last one, pi over 2, plus any coterminals, so plus 2 pi n. So we end up with 3 separate solutions for that. Let's just finish off this page and we'll take a break on the video. So we got 2 times the cosine of 3t minus 1. Same type of deal as we've done in the past. We're going to solve this algebraically. We'll add 1 to both sides. We got 2 times the cosine of 3t equals 1. To keep solving for t here, we're going to divide both sides by 2. We got the cosine of 3t equals 1 over 2. Now, one thing I've kind of glossed over on the previous couple of problems is technically to get rid of the cosine on that left side, we're going to have to do the inverse cosine on both sides. Now I'm going to rewrite this. So inverse cosine and cosine cancel out. Let me also zoom in on this. Inverse cosine and cosine cancel out. So on this side, we're just left with 3t. On the right side, we have the inverse cosine of 1/2. So 3t equals the inverse cosine. Where on our unit circle does cosine equal root 3 over 2? 1 over 2. So we go to the unit circle. We look for where our cosine is equal. Let me clear out some of this stuff, We look for where our cosine is equal to 1/2, and we find 2 different places. We find it's up at pi over 3, because the cosine is 1/2, and also 5 pi over 3, because the cosine is equal to 1/2. So we're going to say 3t equals that pi over 3, or 3t equals 5 pi over 3. Now to solve for this, we also do need to talk about those coterminal angles. So it could be pi over 3 plus 2 pi n. And then on the other one, it'd be 5 pi over 3 plus 2 pi n as well. So those pi over 3 and 5 pi over 3 and any of the coterminal angles. Now the tricky thing here is we don't have t all by itself. So we got to divide both sides by 3. And on this one, we end up with t equals pi over 3 divided by 3 is pi over 9 plus 2 pi n divided by 3 is 2 pi n over 3. Same thing on the other side. Divide both sides by 3. We got t equals 5 pi over, in this case, 9 plus 2 pi n over 3. So we got to make sure we find the coterminal angles and also make sure we're doing the operations on those coterminal angles.